Okay, guys, just like it says on here, you can put these first four into your calculator, and when you do, make sure you use your little caret button. 64 to the 1/2 power. Hopefully, when you type that in, you saw that the answer was 8. And make sure when you type it into your calculator, you do have to put parentheses around it. So let me make sure you understand. Like I'll show you 100 to the 1/2 power. You would put 100, then the caret button, but you have to put your exponent in parentheses. So you do 1 divided by 2. And your answer to that one is 10. But you saw like how I had that plugged into the calculator, how it was in the parentheses. Especially on the older calculators, it doesn't automatically raise both numbers to the exponent. When you do 36 to the 1/2, you see that gives you 6. 4 to the 1/2 gives you 2. So hopefully you're noticing that the pattern is that anything to the 1/2 power is the same thing as a square root. Let me write that down. Anything to the 1/2 power is the same as square root. So something to the 1/2 is equivalent to square rooting that something. So if you would square root 60, ooh, I did not want yellow, but whatever. I did that, both cases will give me 8. Okay, moving along. So that being said, if you use your calculator to determine the values of 125 to the 1/3, 64 to the 1/3, 16 to the 1/4, 243 to the 1/5, go ahead and I'm going to hit pause while you type those in. Okay, guys, so after typing those into the calculator, you should have these answers: 5, 4, 2, and 3. And how else could you write these? For the first one, you could write the 5th root. Oops, my bad. Start that over. We could do the 3rd root, since it's to the 1/3 power of 125. For the next one, we could write the 3rd root of 64. For the one after that, it would be the 4th root of 16. And last but not least, since it's a 1/5 power, it would be the 5th root of 243. So you can see if it's a 1/5, then that's the same thing as a 5th root. Okay, pretty easy. So when you type in 8 to the 2/3, now we have something where the numerator is not a 1. So that's the same thing as type it in, everybody, 8 to the 2/3, and you get 4 as your answer. Okay, so another way that you can write this, like if we go back to the other ones, this, for instance, I'm going to look at number 6. This would be the same thing as 64 to the 1st, and then take the 3rd root of that. That being said, if we have 8 to the 2/3, that's the same thing as the index being a 3. So we have 8 in here, but it's also squared. Okay, so you could do the 3rd root of 64, which gives you 4. Okay. When we write this out, a rational exponent, meaning a fraction, rational is fractions. So another way to write this is, let's just say x to the n over m, generically speaking, is going to be m is our index, x to the n power. All right, so for instance, if I have the 3, let's say 7 to the 3/5 is the same as the 5th root of 7 cubed. All right, so let's rewrite these next ones from radical form to exponential or vice versa. Since this is x to the 5/6, our index would be a 6. We'd have the 6th root of x to the 5th power. X to the 0.4. 0.4, guys, hopefully you know, is 2/5. And so when I rewrite that one, that's like saying the 5th root of x squared. This next one for number 11 says x to the 7/4, so we have the 4th root of x to the 7th. And then last but not least, let's take a look at this one. This is the same thing as since it's in the denominator, basically it's like saying the cube root of x, but it's to the negative first power since it was in the denominator. And so if I rewrite that and I take my index, and you've seen that this denominator number is the same as the index, which means this 3 here has to be our denominator. So this is going to be x, and I'm going to have a 3 in my denominator, but I have a -1 as my numerator. Write the following equations as radicals and then solve them. So we're going to take this first one. It's going to be the cube root of 216 squared. Now I'm going to write it a little differently because it really doesn't matter if I cube root it first or square it first. Personally, because of that little cheat sheet, I would do the cube root first to make it smaller and figure out that the cube root, and I can look at my cheat sheet, is 6. So this gives me 6 inside when I cube root it, and then I have to square that, which I can do in my head, and I get 36. Okay? The next one is basically saying the square root of 9. Remember, square roots we don't write with a number, cubed. So the square root of 9 gives me 3, and then I have to cube that, which gives me 3 times 3 is 9, 9 times 3 gives me 27. All right? And then last but not least, this is saying the 4th root of 81 to the 5th power. If you want to blow the number up first and do 81 to the 5th power, that's your business, okay? Like I said, I usually keep it small by doing the radical part of it first, and then I can blow that number up bigger. Otherwise, I'm going to get a ginormous number that I have to do the 4th root of. All right. This is more simplifying a lot of the same things that we've done in the past. So we're going to do 2. We're going to take care of this business down here first. Okay. So 2x to the 4th, y to the 3rd, and I'm not messing with it. And it's going to be 2 to the 4th, x to the -8. So this now, when I combine my 2 sets of 2's, gets me 2 to the 5th. Add my exponents to my x's, and I get a -4. Y doesn't have any other y's. So 2 to the 5th power. What is that? So that is 32. Y to the 3rd, and then my x's moved to the denominator because they have a negative power. All right. On the next one, I'm first going to clean up the top and make this 6. Actually, no, I'm not. I see a 3 and a 3 that are going to cancel. So I'll just, instead of doing 3 times 2 first, I'll just cancel those. But I do have a to the -7 on top in my numerator, b to the 4th over a to the 4th. Let's take these guys and move them to the denominator and make this a to the 7th down here. This isn't the only way you can do this. You guys know that. So now I get b to the 4th. Oh, I have a 2 up here. 2b to the 4th over a to the 11th. All right. And then last but not least, the same rules apply. Switch colors. The same rules apply. I still have the same base, so I have to add these things together. So I have a 1/2 plus a 3/2. A half plus 3/2 gives me 4/2. 4/2 equals a squared. Cruising right along, same rules, okay? So when it comes to my x's, they both have a base, so I'm going to add those together. I have a 1/2 plus a 1/2. So for my x's, I have x to the 2/2, so they just need 1/2. For my y's, same idea. I have 2/3 plus 1/3. That gives me 3/3 again. That's 1/2. So put these together, and my answer is x, y. All right. This next one, you're going to share the love, just like you always do, and make this distribute to all these parts. So this becomes 4 to the 3rd. Remember, when you're multiplying, you only do, this is like 3 over 1, so it's going to become 6 over 5. And then it's going to become r to the 9 over 4. It says our answer should not contain negative exponents or fractional exponents in the denominator. So when I go to fix this, I have 4 to the third, which I need to fix. And that gives me, whoops, 4 to the third gives me 64. And I don't have any fractional exponents in the denominator. Oops, that's it. So that's my final answer. I don't like how this 5 is written. So I get a 5 here. Okay, and then last problem, we're going to add our x and add our y powers. So this gives me 4/5 plus 2/5. So I should get x to the 6/5. And then I have my y's. I get a third plus a third gives me 2/6, which is, oops, 2/3, my bad. And so my answer is x to the 6/5, y to the 2/3. And all those are fine because none of those are in the denominator. Okay, so now take a pause. You guys try the next two. Unpause it when you finish. Check your answers on G and H. Okay, check your answers. So we had A's that we had to worry about here and C's that we had to worry about here. There's only one set of B's, so you didn't have to combine. On letter H, pretty cut and dry. 5 times 2 divided by 3, 5 times 1 divided by 4 on the R and the S, and then 2 to the 5th power. On this last one, you can see that you have x's in the numerator and the denominator. The 3 is going to stay put in the numerator. But this essentially, in order to get the x's, we have to do 3/2 divided by x, which means 3/2 minus 1, since that's x to the 1st power. So that's basically the same thing as doing 3/2 minus 2/2. So we get x to the 1/2 power. That's not too bad because it came out positive, which means it's in the numerator. So pretty cut and dry on I. Okay, moving along to the next one. This is where it may get a little dicey because on J we have m. So we have m to the 1st minus 1/3. Means we need 3/3 minus 1/3, which gives us m to the 2/3 power. That's positive, so I don't have to worry about that because positive means it's in the numerator. Okay, so that gets me m to the 2/3 over 2 because it's probably going to have that 2 in there. All right, now this next one on letter K, this is where it gets interesting because I don't have any x's that are going to like clean this up where I have more x's in the numerator than the denominator. So what you have to do is come up with how many x's would it take to make the same whole. And then you're going to multiply by that in the top and the bottom. So if you have 1/4, you need 3/4 to make it whole because you can't have fractional exponents in the denominator. One of those weird math rules that we always talk about. So this becomes 2x to the 3/4 over 1x or x to the 1st. Okay, that is how it's going to. Well, in some of these problems, you're going to end up with x's top and bottom and not just one pretty little set of x's. Okay, and then for this one, it's kind of like using that conjugate thing. We're going to multiply by y to the 1/2 plus 1 over y to the 1/2 plus 1. All right, so take a minute, FOIL that out. I'll do it across the bottom so you can check your work. I'm going to hit pause. Okay, I tried to color code everything when I FOILed the numerator and FOILed the denominator so you can see where my connections are and check the colors. Okay, now to clean it up, that gives me y to the 1st in the numerator plus 2y to the 1/2 plus 1 over y to the 1st in the denominator. My positive and negative y to the 1/2 cancel out and I get y minus 1. And so all in all, no fraction exponents in the denominator. That's pretty much all of it. I'm sure you're going to struggle a little bit, but I think you'll be okay. Go back and look at the examples and try to do your assignment. See you guys tomorrow.